All right, hi folks, this is Larry Mussolino. I wanted to record a short video to help get you started on the Module 9 Skills practice. And there's really two main topics in this Module 9. One is working with inequalities, and the other is working with variation equations. So let's do a few examples from both topics. Let's take a look at this one here to get started. It says, graph this given inequality on the number line. And it has this first parenthesis with an and connector. Now, the word and means both conditions must be true. So one way to work this out is to graph part A, graph part B, and then look for where these two graphs overlap each other. So the and connector is going to be considered to be the overlap of the two graphs. I'll show you what I mean by this in a second. So let's do this. I'm going to do part A here. Let me come down here and I'm going to draw a number line. And let me just make a few marks. Actually, I'm going to do, let's do part A. So X is less than or equal to 4. So let me mark this up here. Let's put 0 here maybe. Here's 4, here's 6, and here's 9, let's say. And we need a 1. Let's put a 1 here. All right, so let's do this first part. It says X is less than or equal to 4. So I'm going to draw that as a filled-in circle on the 4, highlighting to the left like this. Okay. The reason I put a filled-in circle is because it's an X less than or equal to 4. If this had been X less than 4, I'd be using an empty circle, but because it's X less than or equal to, I'm using a filled-in circle. All right, the other part of it is X greater than or equal to 6. All right, so I'm going to do a filled-in circle here and highlight to the right for greater than or equal to 6. All right, so we just graphed part A. Let me graph part B. I'm going to do this in blue to make it different. So part B, we want to show highlighting between 1 and 9. So when you see 1 is less than X is less than 9, this means X is between 1 and 9. Now I'm noticing here, this is just a less than symbol. So these are going to be empty circles. All right, so I'm going to do this in blue. So I'm going to highlight 1 with an empty circle. I'm going to highlight 9 with an empty circle. I'm going to draw this blue graph to connect them. Okay, so this is graphing part B in blue. Well, I want the and connector now. This is the last part of the problem. We got to do the and. The and is where they overlap. Well, if you notice right here is an overlap. And right here is an overlap. By overlap, I mean the two graphs are sitting right on top of each other. So if I was to draw this now, here's the answer. Let's draw the answer here. Maybe I'll do this in green. The answer is going to be going from 1 to 4 and from 6 to 9 like this. So let me go to our graphs and see which graph matches. Now I got to be careful here because I'm noticing this is a 15 way out on the right edge here. There's a 15. And so let me just mark these. Here's a 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you notice for the answer we just created, it's graph B. So that's the correct answer here. So again, the way I figured this out was I graphed part A and B separately. And when you see the word and, think about looking for the overlap of the two graphs. You're really asking where do the two graphs sit right on top of each other? That's the answer that you're looking for. All right, let me do another inequality example here. All right, let's come to this one. So this one is asking us to solve this inequality and graph the solution. Well, this is going to be similar to solving an equation, but there's one special rule for inequalities. One special rule for inequalities. The special rule says if you multiply or divide both sides of an inequality by a negative number, you must flip the direction of the inequality. So you must flip the direction of the inequality symbol. All right, you can't forget this rule. Well, to get started here, I'm going to subtract 9 from both sides. That's going to leave me with negative 4x is greater than 20. Well, I want to get x by itself, so I'm going to divide both sides by negative 4. When I do that, I'm going to get x here and a negative 5 on this side, but I just divided both sides by a negative number. I have to flip the direction of the inequality symbol. So instead of being a greater than, I got to flip it to be a less than. So this is my answer. X is less than negative 5. And if I go and look at the graph, this is the graph that would match x less than negative 5. All right, so for this problem, you really had to pay attention to that special rule. It says if you ever multiply or divide both sides of an inequality by a negative number, you have to flip the direction of the inequality symbol. All right, let me do another inequality. Let's do this one. And for this one, we call this a compound inequality because it really has 3 parts to it. There's a left side, a right side, and a middle. Well, my goal here is to get x by itself in the middle of the inequality. Get x by itself in the middle of the inequality. So to start, I'm going to subtract 4 because I want to cancel out this 4 here. But if I subtract 4 in the middle, you have to do the same thing on all 3 parts. So I got to subtract 4 on the left side, in the middle, and on the right side. Well, on the left side, this is a negative 10 subtract 4. That's negative 14. I have a negative 2x then in the middle, less than or equal to 7. All right, well, I want to divide by negative 2 because I want to get this x by itself. So I got to divide by negative 2. So I'm going to divide everything by negative 2. So this is going to be a positive 7 here. There's going to be an x in the middle and a negative 7 over 2 on this side. I'm sorry, this should be a 3 here. My mistake. This should be a 3 up here. 7 subtract 4 is 3, so this should be. But if you notice, we just divided by a negative 2. So I got to use the special rule. The special rule says when you divide by negative number, you got to flip the direction of the inequality symbols. So instead of this being a less than, I got to flip it and make it a greater than. I'm going to flip this to be greater than or equal to. Well, I'm going to rotate this a little bit because this inequality is a little hard for me to understand. So I'm going to rewrite it like this. Negative 3/2 is less than or equal to x is less than 7. So here's my final answer. And this is really telling me x has to be between negative 3/2 and 7. The negative 3/2 has to have a filled in circle because of the less than or equal to. And the 7 has to have an empty circle. So you can see your graph B corresponds. So again, for this example, I had to recognize that I was dividing an inequality by negative 2. But that special rule comes into play. If you're dividing an inequality by a negative number, you've got to flip the direction of the inequality. All right, let's see. Let's do a few more here. Let's take a look at this one. This is asking us for the domain of a square root function. So it says determine values of x that are in the domain. Well, domain is really the allowed values for x. Here's what I got to keep in mind. I could take the square root of 25 and get the answer 5. But if I take the square root of a negative number, negative 25, this is not a real number answer. So what I have to try to avoid is taking the square root of a negative number. This is going to generate not a real number answer. So really what can be under the square root is a 0 or a positive number like this. So the way I'm going to think about this example is to say whatever is underneath the square root symbol has to be greater than or equal to 0. It can't be negative because I don't want to take a square root of a negative number. So to find the domain, I'm going to say to myself, what's underneath the square root symbol has to be greater than or equal to 0. because I'm allowed to take the square root of 0. I'm allowed to take the square root of a positive number. That's allowed. Let me solve this inequality. I'm just going to add 15 to both sides. That gets me 5x greater than or equal to 15. Divide both sides by 5. X is greater than or equal to 3. So as long as x is greater than or equal to 3, I'm taking the square root of a positive number, or maybe the square root of 0. And of course, that's okay. So that's our answer here. X should be greater than or equal to 3. On the number line, I'm going to put a filled in circle on the 3 and highlight to the right. So this is going to be the correct graph for this example. All right. Let's do a few variation questions. Okay, let's do a few variation problems. All right. So here's one that says y varies directly as the cube of x. Now, when you see direct variation like this, the way to get started is to write an equation like y equals k times x. This would be y varies directly with x. This k is called the constant of variation. But this problem said y varies directly with the cube of x. Well, for that, I'm going to get started by writing it as y equals k times x to the 3. Well, we want to find k. That's our first goal here. Well, they're giving me values for y and x that I can plug in. So I'm going to plug in 81 here for y, and I'm going to plug in 9 for x. All right, so let me go ahead and plug and work this out. 9 to the 3rd is, what is that, 729, I think. I'm going to divide both sides by 729 there to get k by itself. Whoops, this k stays. So I'm left that k equals 1/9. So if you start out with this equation, the problem is going to give you a value for y. In our case, it was 81. They're going to give you a value for x that was 9. That means you can figure out k. You can solve for k. So we figured out k is 1/9. Well, then they just want you to write the direct variation equation. Well, remember, we started out with y equals k times x to the 3rd, but we just figured out k is 1/9. So I'm going to plug in 1/9 here, and the final answer that they're looking for is y equals 1/9 x to the 3rd. Okay, folks, so whenever you see direct variation mentioned, you want to write an equation y equals k times x. When they say y varies directly with the cube of x, then you're writing the equation as y equals k times x to the 3rd. All right. Let's do another variation example. All right, here's one similar. So it says here, S is inversely proportional to T. So, you know, in the example we just did a minute ago, it was direct variation. And we wrote it as y equals k times x. But this problem is saying inversely. We call it inverse variation or inversely proportional. When you see that mentioned, you got to write the equation as y equals k over x like that. But they're asking us to use S and T. So they're telling me S is inversely proportional to T. So I'm going to write the equation like this. All right, well, the first thing we want to do is figure out K. Well, they're telling us S and T, so we can plug those in. S is 850 and T is 0.4. All right, so I'm going to just solve this for K. I'm going to multiply both sides by 0.4 because then these will cancel out. So I'm coming up that K equals 340. Well, I can write this equation then. I'm going to replace K with 340. So that means S equals 340 over t. So that's the answer to part A of the question. All right, let's go to part B. Part B says, so this was part A of the question. Part B says, if t equals 5.5, find S. Well, if I have this equation, S equals 340 over t, this is an easy question to answer because I'm just going to plug in 5.5 in place of t. And I'm going to work this out on my calculator and get 61. So folks, the key to this problem was recognizing that the problem is talking about inverse variation. So I had to start out with this equation, y equals k over x. Okay. All right. Maybe I'll do one more. Let's do this one because this is, again, a variation. It says the amount of hydroelectric power is proportional to the flow rate. Well, when they say proportional, that's another way to say direct variation. So I'm going to think of this as a direct variation problem. So the way I'm going to write this is power is equal to K times flow rate. All right, well, the first thing we want to do is find K. All right, they're telling us the dam produces 35,200 kilowatts of power. So I'm going to drop that in here, 35,200. And the flow rate is 2270. Well, this is an equation I could solve for K. I'm going to divide both sides by 2270. And if I work this out, K is equal to, let me grab my calculator here, 35,200 divided by 2270. I'm coming up that K is about 15.5066. Okay. All right, let's go to part B of the question. And here's the question. What if the flow rate is 2160? Find the power. That's what they're asking us. Well, now that we know K, we know what this equation looks like. So this equation now looks like 15.5066 times the flow rate. And the flow rate here is 2160. So when I work this out on my calculator, I'm getting the answer 33,500 rounded. So folks, again, on these kinds of variation problems, your first step is to find K, this constant. Then step 2 is you can use that value of K to answer any question that they ask you, because now we knew that K was 15.5066. So our equation looked like this. They give us a value for flow, so that lets us easily solve for the power. All right, folks, give these examples a try. Please remember you have the view an example or help me solve this button. So please use those for any extra assistance.